Thank you. Thank you very much for your very kind introduction. It's a tremendous pleasure to be here today to tell you a little bit more about what we do at the Microsystems Technology Laboratories and how we collaborate not only with lots of people on campus, but with hundreds of different companies worldwide to make an impact in microsystems and microelectronics, because that's our mission. MTL, for short, is the home of microsystems research and education at MIT. And our definition of microsystems is very broad, going all the way from innovations in materials to systems, microelectronics, nanotechnology, electronic and photonic devices, sensors, biomems, integrated circuits, all the way to system level prototyping. So very broad mission for a very important impact that we think we are playing, because we all know that microelectronics has enabled many different revolutions over the last 75 years. It's because of microelectronics that the computer revolution happened. It's because of microelectronics that the communication revolution happened. It is because of microelectronics that the internet and the AI revolution are happening today. But even though microelectronics and semiconductors and new materials and technologies have been transforming our society for the last few decades, I would like to argue that we are just starting to scratch the surface of the true potential of microsystems. And that's exactly where MTL comes into place. So we are just starting to scratch the surface. How can that be? I mean, we are already making an impact in computing, we are making an impact in communications, we are making the internet and AI possible. But at the same time, microelectronics, I would argue, is the absolutely critical missing piece today to enable personalized, affordable healthcare that can provide better outcomes. If we are able to bring more sensors, more intelligence to the devices around us, I have no idea, I have no doubt that we are going to start a revolution in healthcare. But not only there. Microelectronics is also key for feeding the world. Again, if we are able to bring more intelligence to agriculture, more intelligence to the food production network in our world, I have no doubt that we will be able to increase efficiency and really significantly transform our society, just in the same way we have transformed society for the last 75 years through computing, communication, the internet, AI, etc. Also, there is no green energy without microelectronics. Without semiconductors and without chips, there are no electric vehicles, there are no renewable energy sources, there is, in summary, no green energy. And when we look at the AI revolution and what is enabling the AI revolution, it's all the AI data centers that are coming up all throughout our geography. And AI, it's riding the wave of the exponential improvement in performance that microelectronics, semiconductors, and materials have enabled for many, many decades. So microelectronics has transformed our world, and it's in a path to continue to create new revolutions. At the same time, I would argue that microelectronics also represents one of the most important risks for our society. And that is highlighted in this plot here, which shows energy consumption as well as energy production as a function of time. In green, we have the energy consumption by microelectronics and semiconductors as a function of time, while in orange, we have the world's energy production. And as we see, the amount of energy that goes into electronics is increasing exponentially. And if the current trends continue, roughly by 2035 or 2040, microelectronics and AI data centers and semiconductor-based communication systems are going to be using 100% of all the energy being produced in the world. No energy for food production, no energy for transportation, no energy for anything else than microelectronics. And that's, of course, a problem. And that's also a huge opportunity for all of us. So that's where MTL is playing a very important role in the MIT ecosystem. Our mission is really to develop the next generation of materials, devices, systems, and microelectronic prototypes in very close collaboration with our industry colleagues. We are an interdepartmental laboratory spanning more than 7 different departments and approximately 70 different research groups across MIT. And when I step back and think, okay, what are the key enablers that have made MTL successful? I will summarize them as follows. First of all, the very, very strong community. If you ask anyone at MIT about the different communities that the different labs and initiatives have, everyone will highlight MTL as one of the strongest communities on campus. And again, the community is not only the professors and the students, it's also the staff and especially our industry partners. We have a full commitment to excellence, like everyone else at MIT, and all the different departments that are essential for the future of microsystems are very well ranked internationally, and we take full advantage of that. We also thrive in interdisciplinary research, and because we are a fairly large department touching lots of things, all the way from sensors for food production to healthcare and the future of compute, we divide ourselves in smaller interdisciplinary research communities. And here we have a few of them, such as the Center for Integrated Circuits and Systems, doing everything related to chips and chiplets, or on Medical Electronic Devices and Realization Center, the MEDRC. AI is transforming our world at many different levels, and MTL faculty members are working together in the MIT AI hardware program to make that happen. For power electronics, wide bandgap semiconductors are extremely important components, and again, there is an initiative on that, as there is one on 2D materials as applied to energy, AI, and compute. And we are not stopping there. There are new programs being started all the time. And right now, we are working with our community to get 2 additional initiatives started. One on the future of display technology, both large area displays as well as AR, VR displays. And there is another initiative being started as we speak right now, today, at MTL on the use of semiconductors to revolutionize healthcare. We are also very fortunate to have access to world-class experimental facilities, such as MIT Nano at the Lisa Tissue building here at MIT, which is the state-of-the-art, probably the world-best microelectronics prototyping facility. And if you haven't had a chance to visit it, please do, because it's a really, really impressive place where you can see research happening 24/7. And I believe that there are tours organized for this afternoon, for those interested. We thrive in innovation and we thrive on entrepreneurship. And new startups in this field come out of MTL all the time. And here we have a few of the ones who have come out of MTL in the last few years. And last but not least, we are extremely proud of our very vibrant industrial consortia, or MIG, the Microsystems Industrial Group, that is made of 16 amazing companies that are supporting our work throughout many, many decades. I'm sorry. And this work, as I mentioned, spans all the way from basic material research, AI-driven material discovery, all the way to new semiconductor devices and sensors, putting them together into more complex chips, changing the form factor of electronics. Electronics doesn't have to be rigid like today's computers. Electronics is going to be flexible, it's going to be transparent, it's going to be invisible. And we spend a lot of time prototyping actual systems, all the way from smart fabrics and textiles to insect-scale micro-robots, new biomedical devices and systems, etc., etc. And we don't stop at the prototyping. We also spend a lot of time thinking very carefully about entrepreneurship and the supply chain that is necessary to take all these innovations from the lab to the market. And I would love to work with all of you on this. So we organize lots of different events and activities throughout the year. And I don't have time today to go through all of them. But I do want to highlight a couple of initiatives, such as our annual conference, the Microsystems Annual Research Conference, or MARC. This is the largest university-organized microelectronics and microsystems conference anywhere in the world. It happens every January in a wonderful ski resort a couple of hours north of Boston. I invite all of you to attend. We also have a very lively career fair happening every September, where hundreds of students and companies take part. A very dynamic and active resume site. And also, I do want to spend a minute or so on this program, which goes beyond microelectronics. You know, a few years ago, I asked MIT students, hey, we all know that hardware is the future. We all enjoy playing with hardware and with the breakthroughs that hardware enables. But if that is the case, how is that many of you are actually going into software? And what the MIT students told me, freshmen and sophomore, was, you know what? When we first joined MIT, we were super excited about hardware. Everything from microelectronics to robots to everything in between. But then, as first year and sophomores, we applied to summer internships to hardware-focused companies. And we got rejected from every single hardware company, while we were getting amazing internships in software companies. And that is a problem. We are closing the pipeline right at the beginning. And we started this program, the Northeast Microelectronics Internship Program, to change that, to provide summer internships to first year and second year students throughout the Northeast in hardware-focused companies. This year we have more than 450 students interested in hardware-focused jobs in industry, and I need your help. I need you to reach out to us and provide opportunities for the next generation of technology leaders. And I'm running out of time, but I do want to finish by highlighting that this year we celebrate the 40th anniversary of the Microsystems Technology Laboratory. And for many decades, we have had a very close partnership with ILP in everything related to hardware and microelectronics. And we are exercising this partnership this year by organizing our 40th anniversary celebration at the same time as this flagship ILP R&D conference. So tomorrow, November 20th, in this room, we will highlight lots of innovations that have come out of MTL, the Microsystems Technology Laboratory, over the decades, and looking into the future of healthcare, the future of quantum, the future of energy. And I'm very much looking forward to seeing you all tomorrow at this event. Thank you so much for your attention.